Okay, so we are today we're going to working on logarithm. We'll spend uh, today and the next week on that. Well, logarithm sounds scary, but actually it's pretty simple. It's really can't understand the terminology. It's kind of like when you're reading I don't know, law documents or the lawyer wrote stuff, and there's a lot of vocabulary to understand. But the essence, I mean, what a lot of things that sounds difficult, but actually is simple. But because we don't not familiar with the vocabularies, so that looks difficult. So uh, now, before we do the logarithm, we're going to do a little bit review on exponent because they are related. Exponents, we know that when we write something like, say, 4 to the third, that just simply means 4 times 4 times 4. Now, if we, in general form, if we got something like, say, b to the nth power, it just means b times b times b, and we got n b's multiplied together. So that's the definition of exponent. And the operational exponent actually is quite straightforward. So for example, 10 fifths times 10 to the second. Well, we got 5 10 multiply. There's 2 10 multiply. So altogether is 7 10 multiplied. So we just write as 5, 10 to the 5 plus 2. So that 10 to the 7. Okay, are we good on this one? Very good. Or could have something like, say, 7 to the 9 over 7 to the 5th. Well, this, we know that just 7, 9 minus 5. We got 7/4. Okay, we good on this one for the division? Okay, now we got to something, if we have something like together, is so the have a parenthesis, like say 5 to the third power over to the fourth power. In this case, actually, 3 times 4, we got 5 to the 12th power. Yep, we good on that? Okay, so therefore now we just kind of refresh on the, hello, Jet.
How's it going?
Good. We are just doing a review on the exponent. Then we're going to talk about logarithm. Okay.
Logarithm?
Yeah.
Woo.
So we write like this. That's for the exponent. And if you do the divide, then we got b n minus n. So one is add, one is multiple. So the multiplication turns into addition, and division turn into a subtraction. It's because we're dealing with the exponent here. And we also have this, b to the n's, the m's, then that's b n times m. Okay, are we good here? All right, good, Jet?
Yes.
Okay, you can just give me a thumbs up emoji, okay?
Sure. I can do that.
All right. All right, so we have that. Then from that, we actually something we know that b to the 0th power, that is 1, and b to the negative n, that is b, 1 over b to the n. Yep, okay on this one?
All right.
Okay, so now we're going to looking at logarithm. Logarithm, if I write something like this, we know 10 to the second power is 100. Okay, and we know this one is called base. 10 is a base. and this is exponent. And now this exponent also has a name called logarithm. See, this means means the same thing, a different name because we are it's come from in a way kind of different minor branches of math. Sometimes if we have different context, we could have different names for the same thing. So this one, the logarithm just means the exponent. And this number is called anti-logarithm. Okay, and we have a way to write it is, in this case, if we want to, if we write something like this, log 10, which is, this is the base, 100, what do we mean? So this symbol just means that if we write 10 as base, we write 100 as exponent of base 10. What is the exponent? Well, we know that 100 can write that 10 to the second. So the logarithm of that is equal to 2. Good? Yeah, so now it's trying to understand this in a way, this is a kind of a new operator, and we're trying to understand what that means here. Okay, so then the base could be different positive number. So if I write this as, this is base 2 log and 8. So this just means if I write 8 as exponent of base 2, this is our base, then what is our exponent? We know 8 is 2 to the third, so that gave us 3. Good? Okay, let's try something, okay? You can just type on the chat. What is log 3, 9? Good job, Tammy. Good job, Morgan. Okay, well, we know 9 is 3 to the second power, and this log just means what is the exponent? Well, the exponent is 2, so this is just 2. Okay, Jeff? Okay, now what is the log 5, 125? Good job, Tammy. Yeah, good job, Jet. Oh, okay, 125. So this says if I rewrite 125 as exponent of base 5, what is the exponent? Well, we know 125 is 5 to the third power. So therefore, we got that answer is 3. Good. Okay. Let's try a couple more, okay? Just get used to it. Good job, Tammy. Good job, Jet. Yeah, good job. So we know 16 is 2 to the 4th. So we can find that. Okay. So now of all the logarithm, there are 2 special ones. One is base 10, one is base e. So base 10 is this. We know this one give us 2. And in our calculator, we'll see something like this, log by itself. And that means base 10. There is another, this is called common log. So the base is 10. There's also something called natural log, and that got used in physics a lot. That is base e, the special number e, which is 2.7 and 2 point that and okay, special number. So the base e. So right. So instead of writing like that, on our calculator, they use ln. So that means it's natural log. Okay, I'm going to show you on the calculator. So on your Windows, you should have a calculator, and you set that to scientific, and this is what you see here. Okay, for scientific calculator. All right, and you can see there is a oh God. You can see that there is log here. That is log base 10. And we have here ln, that is log base e. So if you ever wonder what those are the 2 logs, common log and the natural log. So if we want to figure out, say, log 10, now something's easy for us to do, but if we want to find the log 10, base 10 of 23, what's that? Well, we just go click on, depends on how they do it. Some computer, the order, some calculators, different order. So you can see that log 23 get 1.3617, just keep going. So that's how you can find a log if we run into a situation like this. And let's see. We go clean this up. If we want to do, say, natural log, say 45, and you can just type 45 and then take a natural log. And you can see that natural log parenthesis 45, so we got 3.800. Okay, are we good on this one? Okay, very good. So I have you try a couple. let's see. Type, let's say trying to figure out log 10 to the 1000 and see what you got. Got Tammy? Yeah, good job, Morgan. Okay, so if you type in 1000, then natural common law, you got this 3 because 100 1000 is 10 to the third, right? So we know it has to be that. Okay, Jet. Okay, now let's do this one. Log 49. And you just need to keep to the 100th digit, okay? You don't have, otherwise it become too long. And see what you got. Yeah, just to the 100th digit. Yeah, good job. Good job, Tammy. Good job, Morgan. Very good. So we got 49, we got log, and so 1.69, since we just only need to go to hundreds, we just keep to 1.669, and that's it. Okay, now let's try natural log. Let's do natural log 10, see what you got. And we just keep to the 100th digit. Mhm. Very good. So we see that 10 natural log, we got 2.30. Okay. All right. And now, all right, well, let's go do a couple problems. So that you might have to think a little bit. So we're trying to figure out if we natural log y is equal to minus 0.0325. Well, we understand that the log y just means when this is a natural log, we just say if y write as uh, exponent of base e, the exponent will be this. So therefore, y should equal to e to the negative 0.0325. Now, how do we figure this out? Well, we have this this keyword, x to the y's power. So what we need to do is we're going to click on this first. Oh, the wrong one. Let's clean this up. So we go do the base first. The base is E. So there we see there's the E here. That's a very important special number right here. And so we just do E. Then we take the base. which that is the base. Oh, I haven't cleaned up yet. Okay, E, that's the base. Then we do negative 0.0325. Actually, we type number first, then put negative. And you can see that we'll get this 0.96. If we round it to hundreds, that's 0.97. Okay, let's see. Another example is what happens if um, log x is equal to 1.32. Then, so this number, just we know that's a logarithm, which is basically the exponent. So therefore, x, our base is 10, so it's base to the 1.32. And we go there, we type 10. Well, we have that here already in this special case. So we can just use that. Here, we can use that. And you can also use that one, no problem. But the 10 to the base just can save us a little bit of time. I'm going to show you both. 10 to the 1.32. So we got this number. Or we can just go 10, 1.32. Oh, then plus 10s. Good? Yeah. All right. Okay. Have you tried couple? Um, okay. Well, I- log x, that's natural log, equal to 62.5. What is our x? Yeah, that should be okay. What you got?
You would use 10x for this, right?
Well, this is a natural log. Actually, it's e to the 62.5.
Oh, okay. Thank you.
Mhm. Got x equals to e to the 62.5.
Oh.
Well, let's see what we got. We go e to the power of 62.5. And you can see that that's a big number. You see that?
Oh.
That's a huge number.
Ooh.
That's e to the 62.5. So all we need to do is e, then to the power to the 62. 0.5. You can see that. That's a huge number.
Oh,
Good?
I wish my
So it's a-
bank account had that many dollars in it.
Yeah, you would like have that much dollars. Okay, are we good on this one?
Yes, I think so.
Okay.
It didn't when I entered it, it didn't pull up as a whole number like that, where it's not technically as a decimal there, but it pulled up as a decimal. So it pulled up as 1.39124 and so on.
Well, sometimes they use the scientific notation, so they'll write as 1.39 E of something, right? Is that what you see there?
No.
Yeah, it shouldn't just be 1.39. So
It wasn't just that, but it didn't include an E.
what else after that?
Well, there's 1.3912498813 times 10 to the
Yeah,
27th.
yeah, you could have that too. So that's scientific notation. That's big number. So you have to include that, the 10 to the power 27. Good.
Oh, okay. Yes.
Okay, and I don't know, does this one change to scientific notation? I'm not sure. Does not give that option. Maybe the setting. No, not really. No. Does that mean? Yeah. Okay. Let's try. Um, uh, let's try log x equal to 2.136. Mm-hmm. Yeah, Jed, what you got?
Trying to navigate my calculator here for a second.
Okay.
Okay, that's just that be over 10. No. 2.1.
So x will be 10 to the 2.136.
Yes, that'd be x to the y. That'd be how in the world? 10 x to the y. Why does it keep going to 0? Hello. 136 equals. Oh, okay. I think I found it out.
Okay.
0.77. Da, 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 da. Okay. Is that correct?
Mm-hmm. Yeah. So is 2.136, then we use 10 to that. Yeah, so you can see that. So if you round it to hundreds, will be 136.77. Okay. Yeah, good.
Mhm.
All right. Very good. So
Yep.
basically what is the logarithm. But now we're going to learn some rules. And that actually is corresponding to the rules for exponent. So the first thing we is we got the log, say 10. If I got 1 here, what is that?
I maybe
What's that?
I
No.
no okay. Log of 10 to the 1 0.01.
0,
What you got?
0.
0. Because why? Because 1 is 10 to the 0th power, right?
Yeah. Okay.
Okay. Well, how about that if I write as 8 and 1, what we have
0.
is still 0 because 1 is any base to the 0th power. So it doesn't matter what base I am, this is always 0. Good. And so now we're going to look at some rules. I am going to use just natural log to write out the rules, and that applies to any log. Okay, if I'm just using a natural log, well, let's say use common log. We got this log A times B that equals to log A plus log B. So that's first rule. If you write this couple examples, 7 times 8, then we can write as log 7 plus log 8. So now, remember we did early on, Bn times Bn is equals to Bn plus n, right? Okay. So that's where they come down to the multiplication became the addition of the exponent, because what we're doing here is this two number multiplied. What is the exponent if we write as a base 10? And we know that once you change that, then you just add together. So we can actually proving it based on the definition. So let's see. Because we're looking for base 10, we can say A, we can write down as base, let's write as n, and B as base to the m's power. So therefore, A times B is 10 to the n plus m. So therefore, log AB then will be equals to n plus m. Well, what is n? Say here, from here, we know that n is log of A. And from here, we know that m is log of B. So therefore, log AB multiplied, it becomes log A plus log B. Yep. Are we okay on this one?
Yes.
Okay, let's see what can we do. Let's write log, say 9 times 5, then we can write as log 9 plus log 5. Now, if you have log 7x, then we can write as log 7 plus log x. Okay?
Mhm.
Okay, that's our first rule. So let's do a couple of those. Log 8 times 3, and see what you got.
Do you want me to write it as log 8 plus 3 or actually add them together? And
Well, we just write down as what I did here.
oh, okay.
Wait a minute.
Okay.
Yeah, very good. Good job, Toby.
Plus.
Yeah, good job, Morgan. Yep, very good. Very good. So
Simple.
easy, right?
Very, very.
Okay. So now we have that. Then we got into something is come from this rule. Remember we have this our first rule, log AB is log A plus log B. Now our second rule has to do when we have log A to the nth power, and we got something like this, n times log A. For example, log 3 to the 4th power, we simply write as 4 times log 3. Now, the reason for that is come from here. Because when we have a log n, well, it's like a log 3 to the 4th, what we have. It's basically just log 3 times 3 times 3 times 3. According to this rule, we just write as log 3 plus log 3 plus log 3 plus log 3. So therefore, that is just simply 4 log 3. Good? Okay. And if you want to show how to prove our second rule, we know that we can write as log A times A times A. We got n of those. And so therefore we got log A plus log A and log A. We got n of those. So therefore that is n times log A. Yep. Good. Okay. So we have the second rule. Then we can look at the third one. And you can see that this rule is similar to when we have a to the n times m. So that is a to the n times m is multiplication here. So let's looking at the division. When we have log a over b, and that actually is a log a minus log b. So if you have something say log 9 over 7, we can write as log 9 minus log 7. Yeah. Are we good here? Thank you, Morgan. Thank you, Tabby. Jet? Okay. Now, we can also prove this. And that's the key, is understand why that works, not just the how. If you understand why, the how it just become easy. Well, we can see that a over b, we can write as 10 to the n over 10 to the m. And so a is equal to 10 to the n, b is equal to 10 to the m. So therefore, this equals to 10 to the n minus n. Now, because that, then our log a over b, that will be equals to n minus n. Well, we know, based on this, we know n is log a, and m is log b. So we got log a minus log b. Yep. Good. Okay. So let's try couple. Log 5 over 4 and see what you got. Very good. Okay. Yeah. So I'm going to basically I'm going to write the rule for exponent, rule for logarithm, and you can make a comparison. That's exponent and a logarithm. Remember, logarithm basically just the exponent logarithm. Okay, we got let's say bn times bn equals to bn plus n. We got log a times b equals to log a. I'm going to write actually xy, so you won't confuse, because this bn on the left and different from b on the right. So log as xy, then that's log x plus log y. That's the first one. Then we got b, n, and m. That's b, n, and m. So log x to the nth power, that equals to n log x. And mostly n is b n minus n. So log x over y is give us log x minus log y. Okay. All right, so let's do some work. We got log x times 4. Well, that's right. That's right. 4xy. And that will get log 4 plus log x plus log y. And if we got log, say 3x squared times y to the third, then we know we got log 3 plus log x second plus log y to the third. Then this still log 3. But this one become 2 times log x and plus 3 log y. Yep. We good on this one? Okay, Jet. You good? All right. So I'll let you try one. Log 5 x to the third times y to the second, and see what you have. Yep, I'll be right back. Okay, good job. So we got log 5 plus log x to the third plus log y second. And then we got log 5 plus 3 log x, then plus 2 log y. Very good. Jet, it just needs to combine the like terms. Okay, let's do log x to the third times y, then and 4 times z, and see what you have.
What in the world? Log uh Gonna be minus log of the 4.
Yep,
C.
yep, Tammy.
So that'd be log x, log y, so that'd be log x to the second plus log y is log x to the third, and that'd be x to the third. Second is log 4 log z. Okay. Log x raised to the power of 3 plus y power of 2 minus 4.
Okay. Very good. So, well, let's see this. We know this top part here. We can write this as a group is x3 times y minus the bottom group 4z. So that gives us log x3 plus log y. On this side is basically just log 4 plus log z. And so we got 3 log x plus log y, then minus log 4 minus log z. Good?
Okay.
Yeah,
Yes.
make sure the sign's there. Jet, you good?
Yes.
Okay. All right. Let's do one more. Y, sorry. Dot log and 3 x squared y third and the fourth in the 7 second.
Oh my goodness.
Yeah. Yeah, make sure you break them all. Yeah. Okay. All right. So we got, yeah, and Jet, you forgot to move the exponent out. So we got log 3x squared y to the third minus log z fourth times 7 squared. So what we got here on first one is log 3 plus 2 log x and plus 3 log y. Okay, make sure the top here, that's all positive. And then we make the second one minus 4 log z plus 2 log 7. And so what we got there is log 3 plus 2 log x plus 3 log y minus 4 log z minus 2 log 7. Yep. Good.
Okay. I think I understand it now.
Okay. Jet.
Still copying it down.
Okay. So you break it. That's good, but you have to, the exponent needs to move in front to the log.
No, I see what you mean.
Good.
Yeah.
All right, so that's what we have. Very good, very good. Normally that takes a couple weeks in school, but we did that just in an hour. Good job. Okay, I'll see you guys next week.
See you next
Okay.
week, Dr. Thank you very
Yes,
much.
thank you.
Yeah, you're
Thank you.
welcome.
Bye.
Bye.